Hey guys, how's it going? This is Mac and Cheese here for the Mac and Cheese Ascend Infrastructure Show. Yes, nailed the directions. That is Mac.
That's Cheese.
And we're going to be talking about why Kubernetes is terrible for big data today, and yet somehow the best choice for a big data company. So getting right into it, we are Mac and Cheese. Joe is my actual name. We work at Ascend. We support the big data Ascend data platform that runs across three clouds: Azure, GCP, and Amazon. And admittedly, it may be confusing that we are talking about Kubernetes being terrible for big data, but also the correct choice for us. So jumping into it, Kubernetes, it's really not great for big data workloads. We're going to give you some detail on that, but honestly, running big data workloads is not the hardest part of our jobs, and that influences a lot of our choices. But what problems do we really need to solve? It's mostly around operations. The key is that the value that we actually deliver is primarily in supporting other people and not in optimizing big data per se. And this is actually where we kind of get to Kubernetes in supplying a lot of the value that we need there. So following that, we'll dig a little bit into, is Kubernetes a complete picture for the story we're trying to tell there? So digging in, Kubernetes is not, strictly speaking, a big data system. I mean, like, it kind of is, but it's not optimized for big batch data workloads. One of the simplest ways that you can see this is there's no concept of gang scheduling. This is something that's common to resource managers like Yarn, where when you start to actually run a workload, you want to be able to run all of the pieces of your workload of your Spark cluster all simultaneously, and you don't want to run any of them until you can run all of them, because that's how you ensure they're going to finish at the same time and get high utilization. As you're running big data workloads, something that you find is at some point you will schedule some multi-zone cluster, and big surprise, Spark gossips, and it sends data back and forth between its executors and its drivers over the course of a job run. And what you will quickly learn is that can be an immense amount of data, and in the cloud, if you send data out of a zone, you're paying for it. So if you're sending all the data for the job in and out of zones constantly over the course of the job, that gets very expensive very fast. So
yeah. The reliability really comes through the product. With Kubernetes, especially inside of all the clouds, you have a really highly opinionated reliability. Not so good for big data processing.
Exactly. It's really optimized for more of an API and service-based workload where you're not dealing with that same sort of pattern of data transfer. The next big piece is that auto-scaling really isn't particularly well optimized for batch. Again, it's more optimized for persistent services. So what you'll find, again, fairly quickly, is the clusters don't actually scale down particularly well, which admittedly is a hard problem, but more aggressive options would be really great for that, and the tuning is very limited. This one's a little bit minor. Startup and scheduling time is kind of slow, not crazy slow, but just slower than you want. But a little bit bigger is the issues of the actual Spark integration with Kubernetes, which is relatively limited. It has improved a lot with Spark 3, but we basically had to hijack the Spark init script, figure out what payload it was actually sending to Kubernetes, and then do that ourselves, because that was not at all operable in a real way. And the last main thing is, frankly, you need really good bin packing when you're trying to scale up these very large workloads. And Kubernetes does do bin packing. It doesn't exclusively do bin packing. It does a lot of things, and it's not necessarily the order in which we would prioritize those actual priorities at the scheduling layer. So moving on, though, this all only sort of matters. Running big data workloads is actually not the hardest thing that we do. We run into a lot of more challenging issues. When you are running these workloads, what you'll actually find is that the pattern of your failures tends to happen all around startup. Because as you launch these batch workloads, you're typically scheduling a lot of jobs at the same time. This is partially an artifact of the way in which we schedule, where we will evaluate valid jobs to perform. And when new data comes in, you typically will validate many new jobs as ready to run simultaneously. So you then schedule a ton of jobs simultaneously, and they all come up, and they all need to know where Google is. So you end up bringing down your DNS because it doesn't have this nice continuous scaling load. It has this very, very abrupt requirement of servicing a ton of different DNS requests all at the same time. You can have similar issues hitting your the etcd backend of the kube API. We've actually seen the cert authority, particularly in EKS, has become unresponsive sometimes at deployment. So these are all kind of painful, but the way that we actually address them has more to do with our business logic than with our infrastructure. The infrastructure recovers quite well. So this is, an artifact of Kubernetes and the cloud providers giving us a lot of those availability guarantees and the eventual consistency that allows us to assume that, grand scheme, things are probably going to be okay. Like there are hard failures, but there's also a lot of soft failures, and that's what these end up being. So additionally, because of the nature of our systems, failure is built in as something to expect. So when we have a batch job failure, where that might be difficult in a system where you have a hard time keeping track of what you're doing, we have that built in by default. So the scheduler just retries the job, very similarly to how Kubernetes will reschedule a pod if it goes down. So if we happen to have 10, 20% of our jobs fail on DNS lookup when they kick off, we reschedule them, and pretty soon they're all humming along just fine.
Yeah, Joe, that's one of the really amazing things about Kubernetes. We get a lot of API retry logic built into the product. So along with our retry logic, Kate's is in the background doing a lot of amazing work for us.
Exactly. And this all plays into the theme of us getting to take advantage of a lot of other external systems as we are building our platform. So like I said, second part of this, don't solve the problem yourself. Pay someone else. Google, Amazon, Microsoft, they are all invested in building effective Kubernetes solutions. So pay them. Let them do it for you.
Yeah, from our experience here, we've worked with COPS and some other tooling in the past, and the maturity of the cloud product is out in front. So use it.
Yeah, COPS is fine, but there's still easier ways. And the driver that we actually see here is that getting 100% optimization, or even 90+% optimization of a system is hard. that getting the first 80 is pretty easy. So if you run around getting, 80 and change percent effectiveness on a whole lot of different systems, that's much more valuable than getting, the last 10% on one system because you can't afford to do anything else because that's taking all your time. So we don't. We support a lot of things. There's two of us. So what we actually end up working on is purely driven by how we deliver value to the business. So we don't primarily deliver value by making things more efficient. We have other engineers who are really good at that. It's hard to make things more efficient at the infrastructure layer because the best thing you can typically do is bin pack better and turn things off faster, which is sort of easy-ish to do, but also sort of hard-ish to do. And there's a lot of edge cases that are very challenging. But when you're at the actual business logic layer, someone can get some insight that allows them to say, well, there's actually this entire 70% of work that we actually don't need to do at all. And then they just never run those jobs. And that's not something that I, like Mac or I, ever has any access to do. We don't have visibility into that level of the logic. So let someone else solve it. They're really good at that. That's why we hired them.
Yeah, Kubernetes allows our development team to work really close to the infrastructure with things like, infrastructure as code, Terraform modules, and things like that. The developer really gets to see and operate the infrastructure too.
And it really helps us to move in concert together in a way that I haven't gotten to see before now. So what we end up actually doing is we do a lot of just empowerment of our developers. We are in a support role. We are building infrastructure for them to run on. We are building infrastructure so that they can deliver value to our customers. How do we do that? So there's basically two main ways in which we can deliver that value. The first is we expand the target market, the actual viable customer space. So by expanding to more clouds, we were on 2 clouds when I joined with a sort of weird split product, and now we are on 3 clouds with a very, very consistent story across all those clouds. Being able to support connections to private data sources, whether it's in an on-prem data center behind a VPN or an SSH gateway or whatever, building our security and compliance stories so that we can make sales to those big enterprise customers who have those needs. And just generally building this into a product that is a commodity rather than a bespoke installation for customers allows us to change the actual cost of running it and sell it to more people.
You also get the opportunity to bring a lot of the solutions, like the connectors you were discussing, connecting to any service. Kubernetes allows us to build these solutions inside the cluster, as opposed to trying to figure out how to get it into a data center or something like that.
Exactly, and this changes our actual strategy around how we connect to things. Like we can double down on a specific cloud connector, or we can say, well, you know what, we're on the same platform everywhere, so let's just use that. And that's been a game changer. The second big piece is just making the Ascend infrastructure very easy to consume for our developers. So the key here is developers don't have to think at Ascend largely about deploying to Google or Azure or Amazon. They think about deploying to Kubernetes. And because of that, they don't need to rebuild something 3 times. They build it once, they make a couple config switches, and that's it. So a single API for deployments, a single API for auto scaling. It's the same story everywhere. How do you make things stable? How do you make them secure, highly available? It's all managed through one interface.
It decreases the cost or the amount of time that we spend prototyping. We don't have to provision, VMs and things like that, or get capacity, requirements fulfilled. We just turn some pods on.
Exactly. You spend, 2 weeks working on a feature. You spend one more day with little patches that get it to the rest of the clouds. Like, it's a trivial amount of additional work. So we may have stepped back a little bit, but we're talking about Kubernetes here. That is the actual empowering component that drives all of this. Kubernetes is, bar none, the only tool that can support what we do. There is no remaining war amongst the cloud resource managers. Like DCOS is not a viable option anymore. Nomad never got that kind of traction. Yarn doesn't do this. Docker Swarm, like the game was played and Kubernetes won. What that means is it gives us a single deploy target across all clouds because the support has been built out for that. We don't need to build the actual cloud providers ourselves because every cloud is offering a managed Kubernetes service. We just spin them up. They have their quirks, they're not all built, they're not all created equally. For example, the EKS solution requires 10 times as many resources as the Azure or Google solutions. But once you got it up, it just runs. For the most part, we pretty much spin these up with Terraform, and then we just treat them like Ascend environments. We don't think of it as, this special, like, this one is Azure, this one is whatever cloud. It's just an attribute that they have that changes some switches. That doesn't change anything fundamental. So we just deploy the code and don't think about it. And it works. The other huge component of this is the Kubernetes ecosystem is moving faster than anything I've ever seen in technology. They are releasing several minor versions a year. Every single one has big new features. I'm really begging the providers, cloud providers, to hurry up with their support because I would love to get to Kube 118 so we can get a kube control debug.
Oh, that'd be nice.
What's that?
I said that would be nice. Thinking about the adoption for the clouds, we're also starting to see a lot of actual hardware vendors adopting these techniques and APIs. So it's not just the cloud racing. We're seeing on-prem hardware actually starts to adopt this stuff too. Exactly,
and this actually, because one of the things that we're sort of looking at on the future is how could it possibly tell the story of Ascend in an on-premise environment, where we don't have the advantage of these cloud providers, and that exact sort of traction is what's going to end up enabling that, because we can look at people like MinIO as a blob store provider, and your gravitational or Spectro Cloud or whomever as a Kubernetes provider in an on-prem environment. So we continue to actually gain the benefits because of that rich ecosystem. We don't have to build all these features out ourselves. And again, we're two people. Like, we don't have the capacity to build all this functionality ourselves. So this actually is the only way that we can do it.
Yeah, even just on the topic of storage and MinIO, it's an abstraction layer now. We really get to enjoy a programmable interface, and where before storage was, especially for big data, this really hard thing to do.
right? And it's another example of this is tools like Rubix. So I mentioned the lack of gang scheduling earlier. Rubix is something that was built by Palantir. It helps to mitigate some of the problems of Kubernetes not being optimized for big data workloads. So again, it's the ecosystem. Kubernetes isn't ideal for this, but it's improving, and we don't have to build it. So huge deal there. But you get a little bit further, like, okay, so you're going to use Kubernetes for all of this. Does it actually address all these operational problems? I was actually talking to a buddy of mine the other day who was saying that Kubernetes, it makes the impossible problems hard, and it also makes the easy problems hard. But they're all solvable. So it doesn't tell the complete story on its own. You do still need to do a lot of work, and you need to actually have a plan and understanding of the systems that you're working with in order to address those complications. For example, how do you launch Kubernetes? We use Terraform to launch Kubernetes across all of the clouds. That actually was not a small endeavor. Even with cloud providers in place, in some cases, it's relatively straightforward, but every cloud still has their quirks. So as you're laying that base layer so that you can have this same level of an abstract foundation to build on top of, you have to implement the mapping from the base substrate to your layer. And that's not nothing. The authentication story, again, every kube provider has its own authentication story, because the back end in K8s is very abstract. It supports a lot of different things. It supports shell scripts as a method of authentication, which Amazon took advantage of. And like, valid approach, it does add complications when you're trying to actually manage all of this. And then there are also the differences that Kubernetes can't abstract away. So, you talk about your, for us, it's blob storage. So, we work with Azure Blob Store, we work with Google Cloud Storage, we work with S3. The block, your block volumes for all of your persistence. For example, our Prometheus needs a persistence layer. It runs on top of Kubernetes. We happen to need to know the name of all the different storage types across all the clouds, because that has to get formatted in. Network layers, they all have their own little quirks, and we have to learn about each of those as we go before we can really just set it and forget it. The whole security story. Kubernetes is an immensely complicated system, which means that there's all sorts of special ways in which you can get configuration wrong and create security holes.
Kubernetes, I think, is probably one of the first opportunities I've seen where security is usually like this layer around something, or like almost like a topic, right? With Kubernetes, security is actually a feature. And to even roll that even further, especially when they implemented RBAC, we have compliance now as a feature to the actual infrastructure. And it's not something like we have firewalls and IDS and IPS systems all over the place. So again, Kubernetes empowering us to actually think about security as a feature and not so much as this thing we have to do.
And it also allows us to tell a compelling story across our clouds, whereas we talk to our auditors, they say, okay, great, so you're in Amazon, tell us about your security groups. And we're like, well, yes, we have these baseline security groups, but also we drive a lot of this through the actual, built inside Kubernetes, which are portable. It's another unified story.
Yeah. Clouds.
Albeit a complex one. And, these are all teasers for upcoming episodes. We're going to be doing this for a while, so bear with us. We're looking forward to your feedback and subscriptions, and we're looking forward to audience involvement. So rehashing what we just went through, Kube, it's not great for big data workloads. It's fine. It's okay. It gets you some nice things. Not perfect. But that's okay. That's not actually what we need it to do. We need it to provide functionality that supports us on operations and on building a platform that all of our developers can consume easily so that we can expand our market. End of the day, Kubernetes is the only tool that can really do this. But along with that, we've got a whole set of new challenges. So we're not out of jobs yet, thankfully. And we're going to keep working on this. So thanks for watching, everyone. Like I said, we will be doing more of these. We're aiming for every 2 weeks, barring, I don't know, some reason that we wouldn't. Our emails are here. Feel free to reach out. Feel free to drop comments in on the video. We'll be taking feedback. And if there's anything that you'd like to hear us talk about, let us know. So,
yep. Hope to see you all on soon.
Thanks, guys. Bye-bye.